In this video, we're going to be working on the Evertz Master Clock SPG model 5600 MSC. I know that sounds Chinese to you. It's a sync generator. Device looks something like this, and customer brought this in because smoke came out and fans stopped working. Now, we never worked on this device before, and I told the customer that this is something that we have not worked on before. He insisted that we take a look and see if we can help him out with the fans not working. And he's the same customer that once brought the bird dog encoder device, the $2,000 device. He had a damaged HDMI connector and we fixed it for him. So I told him that we will take a look and see if we can help you out on this. Now, before we proceed with the repair, I want to go over a package that we received from Amazon. I opened up the package and I saw things that I did not order. Things that I can use in the shop, but I never ordered those from Amazon. This was inside. Swabs. Tiny swabs that we can use for cleaning. We have a gold shop next to us, so I thought maybe this package came here by mistake. But it does say UNI-T, which is our shop. And I see tweezers. 3 sets of tweezers. And honestly, I have never used these before, so I'm curious to see how those tweezers look like. They appear heavy. I see 3 sets of tweezers. And the third thing inside the box are the gloves. I mean, we use all of those in our shop here, but I never ordered that package. So I was looking into the receipt here, order number. I went to check, that I ordered these by mistake, and I did not order them. And I found this packing slip by Amazon and also a gift for you. Somebody actually sent those as a gift. Hi Alex, I'm Gabrielle and I wanted to support your work, but I'm from Italy and I can't do it in person. I hope you enjoy these little gifts. I work in IT and you help me understand how circuits work. Thank you, from Gabrielle Branchi. So it's a gift from Gabrielle from Italy, and Gabrielle wanted to support the channel, so he just sent those to us. I mean, that's what I'm talking about when I say a lot of people support the channel in one way or another. Some people donate, some people mail stuff over, some people post a positive feedback, some people mail stuff over for repair, others they purchase off our e-commerce site, others they comment, like, share. Everything is a form of support. I really thank each and every one of you who supports this channel in one way or another. And Gabrielle, thank you very much for the gifts. I really appreciate what you sent over. And I can definitely make use of everything that's inside this box. So let's continue with the repair and see what's going on. Now, the customer said that the fans are no longer working and he did see smoke come out. So like I always say, smoke is a good thing because it can pinpoint us to where the problem may be coming from. Smoke means there's a burn mark on the board or there's something blown on the board. So what I want to do is I want to look at the fan connector area and see if we see anything obvious. Where are the fans? We have one here, we have one here. And he said that both of them stopped working and not just one. So one of them is connecting here and the other one is connecting right next. So both of them are connecting right next to each other. So let's take a look at the fan connectors. We see one here and we see, oh, look at this. I see a burnt component here and I see a burnt component here. So we have 2 burnt, most likely N-channel MOSFETs. These are commonly used next to fan connectors. Let me disconnect quick so we can have a better view. And we have 2 blown MOSFETs. Now, I want to make sure that these are N-channel MOSFETs. I cannot read it well, but I think M8. M8, and I do see a line coming down. A line coming down could be a P. It's not going to be an A, it's not going to be a B. The line does not come down like this. If it's A, B, C, D, E, F, G, so most likely this letter is a P. I cannot think of any other letter that would extend down like this. So I'm going to go for MAP. Let's go to s-manuals.com and we're going to look up M8P. So M8 is right here. And is there any M8P? M8A, B, C, E, K, P, right there. You see? Because the line is extending down, so most likely a P, like I thought. And what is this? BSN20, and it's an N-channel MOSFET, just like I thought. M-channel MOSFET. So we should be able to extract those MOSFETs off a donor laptop board and put them on here. That will work. I do not have the BSN20. Any N-channel MOSFET should work in this case. So right now we're going to start by desoldering those MOSFETs. We do have plastic connectors right next to the MOSFET, so applying hot air may risk the connector melting, and I do not want to do that. You see the MOSFETs are very close to those connectors. The plastic on those connectors look industrial, tough, but we do not know how much heat they can take, and I do not want to risk damaging that connector. So what is an alternative way to remove those MOSFETs? Why don't we use low melt solder? And while at it, why not use the gloves from Gabriel and also the tweezer that he mailed over? Those gloves are expensive now. We used to buy them at probably $8 to $10 a box. Right now they're going for something like $25 to $30 a box because of the shortage. We used to buy them in packs of 1,000, 10 boxes, 100 each. And I think we used to pay around $8 a box. Right now, prices are way up for those gloves. Way up. Okay. Nice. And let me use one of those tweezers. We'll go for the fine one. Maybe this one here. Okay, so this one is slightly angled. Huh, look at that. It's not aligned. But I do see screws on it, so maybe we can adjust those tweezers. So I just pushed it up with my fingers, and I think we're good now. Let me check the other one. I mean, this one does not look aligned either. What the? I don't know, is that quality control? With the factory that makes those tweezers? I don't know. I mean, look at this. The tweezer is unusable, I think. Yeah, I wonder if we need to adjust the screws on those tweezers. Let me take a look at the third one. And the third one is not aligned either. Wow. Wow. Gabriel, it's not your fault, but the tweezers are not aligned. I'm gonna check and see if we can adjust the screws to align them. But for now, I'm gonna put them on the side. And continue with the repair. Why would they manufacture those tweezers if they cannot properly align them. So right now we're going to start by applying low melt solder. And that component is out. We did not have to use hot air, just low melt. And just like that. That's the beauty and the magic of low melt solder. But of course, low melt solder without flux is useless. So you need flux in order for low melt to properly flow. You can purchase flux and low melt off our website, along with this braid. Okay, and now we are ready to solder 2 N-channel MOSFETs here. And we should be able to extract those from a laptop donor board that I have here. Let me look next to this connector here. And what do we see here? S72. That may be it. Let's check S72. S7. And then S72, yes, N-channel MOSFET. Great. Right now, I'm not really concerned about the rating on this MOSFET. And I do have the BSN20 MOSFETs on order. We're gonna solder it right here. And we're not gonna solder it using hot air, but we're gonna solder using our soldering iron. Of course, we have to apply flux. And I'm gonna pre-apply solder onto my soldering iron tip. The last one inside is a little harder to reach, but that's okay. That's it. This one is done. Now let's do the other one. Now, once we're done soldering those MOSFETs, we're gonna check on those resistors to make sure that the value is reading properly. They do look burned, but they may still be good. We do not see holes in them, although I do see a burn. A burn can happen from overheating. It's normal on those resistors. Right, so perfect. We have a little bit more solder than we need, but that's okay. The more the merrier. Meter in ohms mode, and let's measure. We should be reading 10 ohms each. And the meter is reading 5.6, which is good. So we do not have an open resistor, and we do not have a resistor that's reading in the mega ohms, and we are measuring that resistor in circuit. So the reading is perfectly fine, and all of them are reading 5.4 ohms, which is perfect. When resistors go bad or they fail, they do not go down in value, they go up. So a 10 ohm resistor measuring 5.6 is good. A 10 ohm resistor measuring 20K is not good, or measuring something in the mega ohms is not good. or measuring oh well is not good. Fume extractor off, and let's power this device on and see if fans will spin. I do not know if fans are supposed to spin as soon as you power this device on, but our job is done. And I do not know how to operate this device. So let's start by plugging the fan connectors. Hopefully nothing is going to blow up. And since I'm not sure what's going to happen, I do see a light on the board here. Right there, I do see a red light here. Oh, fans are spinning. Fans are spinning. Look at this. I do not need the goggles no more. See, I'm touching my gloves onto the fan. And the second one. Yes, done. So we fixed the circuit that controls the fans. Let me disconnect. We're going to call the customer to come and pick up. The customer is local, and I'm sure he's going to be very, very happy with the fix. That's it. I hope you enjoyed this video. Don't forget to like and subscribe. Leave a comment if you have any questions, and we'll do something else in the next video.